The humanoid robot chess game between Tesla and Boston Dynamics is not only determined by pre-programming and AI, but also by the type of powertrain that's integrated within. Instead of opting for a hydraulic drive, like the Atlas bot, Musk developed Optimus with a separate electric drive from Tesla, which he says is the best in the world. Aside from that, the fact that Optimus can walk with its knees bent is the key to saving energy. So, how do these factors determine Tesla bot's future breakthrough? Welcome to Tesla Car World. Please show your support by subscribing and ringing the bell. Now, let's get started with today's content. To assert control over the humanoid robot game, Tesla is aiming to release a limited number of Optimus models by late 2025, according to sources we've received information from, indicating around 100 units. However, we are unsure whether Musk can meet this set target. Currently, Tesla's Optimus project is actively seeking to fill 61 positions. Among the 61 new jobs opened for Tesla's robot, at least 5 are categorized as Optimus production roles. Many perspectives express curiosity about why the Tesla bot moves with bent knees like an old man. In reality, behind this issue lies a significant concept that came from the mind of Musk himself. So what exactly is the reason for the Optimus not being able to walk straight? Well, if we pay closer attention to most humanoid robots today, not only will the Tesla bot perform this type of jaunt, but others, like the Atlas from Boston Dynamics, also have such a bent knee gait. You may not know this, but besides the normal walking style, humans can also walk with bent knees, just not as exaggerated as these robots are doing. Go ahead, try walking a few steps with your knees fully closed and you will feel the difference. So why is the bending more exaggerated in robots? It's a combination of reduced crash damage, force feedback, and a lack of degrees of freedom, or DOF in this case. Each time the robot's legs touch the ground, there is an impact. The stiffness increases proportionally to the straightness of the knee, causing vibrations to transmit to the joints. Humans do not encounter this issue because we are soft creatures with ligaments between our bones, the ability to dampen muscle activity, and other biological benefits. Furthermore, these robots need to react quickly to external forces, changes in terrain, and other non-ideal conditions. I mean, if someone pushes you, you have over 200 degrees of freedom that you can use to reposition your center of gravity, all the while keeping your feet planted on the ground. The Optimus robot, on the other hand, only has a few degrees of freedom to achieve that. The curved legs provides a larger range of motion where external impacts can be compensated for, and they also transmit forces better to adapt and maintain stability. Speaking of, the stability of the robot is enhanced when the knees are bent, as this lower stance increases the contact area with the ground, simultaneously reducing the risk of the Optimus falling. Particularly on hilly or uneven terrain, the ability to adjust the robot's center of gravity by bending the knees helps maintain stability and balance. Evidence of this can be observed in some scenes where Optimus demonstrates remarkably impressive balance control. Its curved knees give it a somewhat slender, deliberate walking posture, but that stance is common for humanoid robots today because a straight-legged posture demands much more precise balance, a factor that Tesla has not yet achieved excellence for in Optimus. But why is Optimus walking on its knees an effective way to save energy? The initial Optimus prototypes will serve the Tesla factory, so the manufacturer's shaping of such a way of moving also brings benefits in terms of the ability to move in narrow spaces. Robots can flexibly move and turn more easily, especially when having to overcome hundreds or thousands of mechanical and human obstacles, as well as making precise moves in narrow spaces between areas and along small walkways in the factory space. It can be seen then that knee walking helps reduce step length, increasing accuracy and flexibility in Optimus's movement activities. Notably, energy efficiency is another benefit of this decision. In the original Optimus Gen 1 model, the 2.3 kilowatt-hour battery pack is not overly large enough to provide sufficient power. Therefore, adopting a crouching posture helps the robot consume energy more efficiently compared to walking with straight legs. And this is all because less energy is required to maintain balance and move while on the ground. Musk's effort in this regard aims to minimize energy loss from a not overly powerful lithium battery system. Ultimately, this becomes especially crucial when the robot operates in an environment with limited energy resources, as well as dynamic areas. Interacting with humans is also an important factor. The lower posture of the robot when crouching helps create a more human-like image, making it easier for robots and humans to gaze upon each other through the eyes, generating a friendly feeling, which could contribute to a better interactive experience in communication situations with users. Despite the evident benefits, Tesla's Optimus is still in the developmental stage, and there may be improvements in the future. Current technological limitations, especially in environmental sensing and motion control capabilities, might make the decision to crouch reasonable. However, with continuous advancements in robotics, there is an expectation that in the future, robots will have the ability to walk with straight legs like humans. This opens up many new opportunities for integrating robots into our daily lives. Currently, we are informed that about 80% of the assembly is done manually by a separate team, a group that transitioned from the development of Bumblebee. The reality is that Tesla is still facing a shortage of personnel in this field. According to Musk, the most significant challenge lie in achieving humanoid robot functionality and developing Tesla's proprietary independent electric drivetrain, both of which are given top priority along with integrated AI. So why is the powertrain so decisive for the development of Optimus? When it comes to the long-term vision, we are confident in stating that Tesla Bot will be more crucial than Musk's EV models. As you know, Musk's ambitions in AI are something quite challenging to fully articulate. Despite having less than 2 years of experience in humanoid robot development, Tesla has opted for a path that is less similar to Boston Dynamics, even though they are globally renowned for their leading robot technology. 30 years of experience. But first, let's talk about Musk's choice of using an electric drivetrain instead of hydraulics as seen in the Atlas model from BD. Getting straight to the point, the reason Optimus is highly regarded over Atlas is not only due to programming methods, but also the fact that it relies on an innovative drivetrain that Musk is committed to. Because of this, one of the superior aspects of the Tesla Bot compared to Atlas or other robots is the mention of energy efficiency. So how can a Tesla Bot work all day on just one single charge? One of the notable advantages of the electric drivetrain, especially in the case of Optimus and the Tesla Bot, is the ability to achieve energy efficiency levels of up to 75 to 80%. T-Bot, with its flexible power consumption thanks to the drivetrain engaging when necessary and conserving energy during idle periods, provides a distinct advantage, whether serving as a homemaker or a factory staff. Furthermore, with higher energy conversion efficiency compared to other drivetrain systems like hydraulics or pneumatic, Optimus can perform intricate and highly flexible movements. This is evident in tasks such as squat exercises, yoga, and even drone dance. Not only that, but the high energy efficiency also translates into significant reduction in energy consumption, allowing the Tesla Bot to operate for longer periods with a relatively small battery compared to competing counterparts. This is partly because Optimus experiences less energy loss due to the absence of friction between its drivetrain components. It's easier to visualize when compared to Boston Dynamics' Atlas, where hydraulic drivetrains typically have efficiencies ranging from 40 to 55%, or pneumatic systems with efficiencies usually between 10 to 25. Unlike electric systems, hydraulic drivetrains have many factors influencing the efficiency of the fluid power system, including temperature, pressure, compressor design, seal integrity, and system leakage. Efficiency often decreases at higher speeds due to energy losses in the transmission and the heating of hydraulic fluid. We're not certain about the extent of energy reduction in the Atlas robot, but when considering a hydraulic drive system, it's evident that the energy loss due to friction between hydraulic components will likely be higher compared to an electric system like Optimus, possibly even posing a risk of oil leakage. Consequently, all these factors factors create a certain gap when incorporated into a humanoid robot, and we speculate that this is the reason why Boston Dynamics is still struggling, despite having been ahead of Tesla by several decades. But what makes the Tesla bot say no to operating noise and big size? One of the criteria that industry experts highly appreciate in the Optimus is its quietness in every step, even during operation. It's evident that Tesla is putting significant effort into minimizing motor noise across all technologies, not just EVs. Proof of this is evident in the latest Model 3 Highland Edition, where both wind and engine noise have been significantly reduced. In contrast to the hydraulic drivetrain system, the Tesla bot only requires an actuator and a relatively small control unit for the drive system, all neatly arranged in the robot's chest. It's easy to notice that engineers have assembled it meticulously to create a well-balanced robot compared to any humanoid robot on the market. Currently, the Tesla bot stands at a height of 5 feet 11 inches and weighs 121 pounds after a 22-pound reduction in the latest upgrade. Notably, the lightweight design allows it to run at a speed of 6.5 miles per hour, a 30% increase. The efficient drive system significantly contributes to achieving these performance specs. When looking at Boston Dynamics' Atlas robot, despite its high agility demonstrated through complex actions such as running, jumping, climbing the stairs, and navigating rough terrain based on pre-programmed movements, the overall assessment of its perfection is considerably lacking. It's important to note that the structure of a hydraulic drive system is quite complex, requiring numerous subsystems, which, when combined, contribute to an increase in the overall weight and size of the system. It wouldn't be an exaggeration to say that the Atlas doesn't resemble a humanoid robot despite undergoing numerous upgrades and modifications. Up to this point, it still appears like a makeshift metal structure standing at a height of 5 feet 9 inches and weighing 180 pounds after the latest update. Wow, sounds like me. In some of the uploaded videos featuring the Atlas robot, it's noticeable that there is sound coming from the hydraulic system. This is inherent because, by nature, it requires cylinders, a power unit to supply oil pressure, control valves, filters, and other auxiliary components. During operation, fluid circulates through the pipes accompanied by pressure on the valves, resulting in noise. This is a significant drawback for the Atlas. So, when choosing the electric drivetrain for Optimus, putting energy efficiency benefits aside, Musk likely considered various accompanying factors. This decision not only contributes to energy saving, but also allows the robot to operate more quietly, minimizing potential discomfort. How do you feel about the advantage of this Optimus robot from Tesla? Let me know your thoughts in the comment section down below. In Optimus's videos, where it folds a shirt in less than 30 seconds, rearranges blocks by color, or handles smooth objects like eggs, we confidently assert that Tesla is investing significantly in the precision that Optimus can deliver. Half of the process is carried out by AI, and the other half depends on the drive system control. So, is this electric drive system better than hydraulic systems when it comes to precision? The hydraulic drive system of the Atlas is notable for its ability to withstand heavy loads and forces because it requires a large volume of hydraulic fluid and a pumping system to generate pressure, making this robot strong and flexible in various situations. However, achieving precise positioning along with the trajectory becomes complicated, requiring the assistance of control valves and operators. Advanced hydraulic servo control systems can offer high precision and repeatability, but this comes with significant costs and complexity. This is why the Atlas is rumored to be priced at $150,000, and Boston Dynamics has not shown commercial signs for this humanoid robot despite its existence since 2013. On the other hand, the Tesla bot utilizes an electric drive system, providing unlimited positioning capabilities according to a standard that is much less complex. This system, once programmed, requires minimal intervention or maintenance to maintain accuracy and consistency. While its weakness lies in its inability to withstand loads like the integrated hydraulic system of the Atlas bot, it compensates with the simplicity and efficiency of AI technology in executing a variety of tasks that Tesla has projected over time. Now here's the big question. How clean and green is the Optimus based on its electric powertrain? Currently, details regarding Tesla's utilization of humanoid robots in EV production at its factories remain undisclosed. As previously mentioned, while the advantages of Optimus are evident, they also present challenges that Musk is striving to address. Despite being a manufacturer with less than 2 years of experience in the field, such as Tesla, the entire concept of Optimus reflects Elon Musk's unwavering dedication to technological advancement and emission reduction. In the foreseeable future, potentially even within this year, Tesla may publicly introduce the Model 2 Redwood production project, featuring Optimus assistance on the production line, a notion hinted at by Musk himself. Unlike traditional hydraulic drive systems, the T-Bot eliminates concerns regarding fluid leakage within the factory environment. Due to the use of a hydraulic drive system in the Atlas robot, it faces inherent issues related to leaks from the hydraulic system. If the Atlas robot experiences oil leakage from the hydraulic drive system, it could lead to various serious consequences, depending on the extent and location of the leakage. Firstly, a minor leakage could cause a drop in pressure within the system, making the robot weaker and unable to perform heavy tasks. Conversely, a larger leak could push the robot into an inoperable state due to the lack of necessary pressure to move its joints. In addition to that, hydraulic oil can seep into other parts of the robot, causing damage to electronic components, sensors, and mechanical parts. Moreover, if oil leakage is not promptly addressed, it can also contaminate the surrounding area, posing risks to operators and creating difficulties in maintenance. Another consequence, if leakage is not controlled, is the risk of fire, as hydraulic oil is flammable. This becomes particularly dangerous if the leaked oil comes into contact with sparks or a heat source. Additionally, hydraulic oil leakage also causes environmental pollution, especially if it infiltrates the soil or water sources. In contrast, the electric drive system integrated into the T-Bot does not have any of these drawbacks. The Tesla Bot utilizes an electric drive system, a solution that typically requires minimal maintenance. This system is compact in size and rarely needs extensive upkeep. In high-performance applications, periodic lubrication procedures may be necessary, but these are often simple tasks with low associated costs. In contrast, the Atlas uses a hydraulic drive system, a powerful but high-maintenance means. Hydraulic fluid-powered devices are typically robust and can be deployed easily, but to maintain stable operations, they require significant maintenance. For instance, routine maintenance involving air and oil is essential to prevent moisture and contaminant buildup that could prematurely degrade seals and other system components. The electric drive system has double the efficiency compared to hydraulic systems, but it may have higher initial costs. However, over the system's lifespan, the total cost of ownership will be significantly lower when considering increased efficiency, system flexibility, lower maintenance costs, improved processes, and lower utility costs. While the leaked pricing of the Optimus ranging from $20,000 to $30,000 may be challenging to realize at the initial launch, there is belief in a lower price point as Tesla achieves significant progress in expanding production and recouping profits. Analysts have speculated that Optimus could become Tesla's main revenue stream when they achieve a production volume of 1 million units per year, surpassing the highly competitive EV market. Considering this, the choice between the electric transmission system of the T-Bot and the hydraulic transmission system of the Atlas both bring about their own advantages and disadvantages, depending on the specific requirements of the application and the significance of maintenance. So, in the end, how do you feel about Tesla establishing a clear future for the Optimus?
Just as in our daily lives, AI and robots are increasingly becoming part of the healthcare ecosystem. A stark reality is that the healthcare system in the United States is indeed very complex. When someone falls ill and needs immediate treatment, they often have to wait until their number is called in the queue at the doctor's office. This can even surpass imagination when you could potentially recover from illness before your turn for medical attention comes up, something many people might have encountered. Since the advent of AI and humanoid robots, healthcare systems seem to have improved. First, you interact with a disease diagnosis model connected to AI within the hospital's healthcare system by describing the symptoms of the conditions you're experiencing. Through synthesized inferences with the medical field, AI provides results and suggests methods for treatment at home or advises you whether you need to visit a hospital. This is the result of a primary healthcare system aimed at reducing overload in hospitals. Tesla's neural network research has the capability to learn and store vast amounts of information across all aspects of autonomous driving technology and even healthcare. Every medical journal, symptom, and related data are utilized for case studies on treatment and coping worldwide. This functionality won't just operate on the typical smartphones we see today. That'll be directly integrated into this new generation robot product. One of the biggest potential benefits of Tesla's new generation bot that the company is focusing on its ability to help people stay healthy so they won't need to visit doctors, or at least not as frequently. Applications in technology encourage healthier behaviors in individuals and help manage healthy lifestyles proactively. It puts consumers in control of their health and reminds them of what needs to be done to avoid complications. Moreover, an issue often of concern is the thoughts of the elderly, based on a small survey we conducted at a nursing home. The results suggest that some of them seem to be here because they don't want to depend on their children. However, some mention that certain caregivers might make them feel dissatisfied with their attitude and behavior. Hence, Optimus promises to bring an entirely new experience. Although it's a robot, Tesla has made significant advancements in its motion capabilities, with 11 degrees of freedom in arm and finger joints. This enables it to proficiently handle medical procedures and daily life care tasks. Elon Musk once stated that it could thread a needle, but in the medical context, it could be understood as administering a hypodermic needle. Robots have been used in medicine for over 30 years, ranging from simple experimental robots to extremely complex surgical robots that can assist or even autonomously perform surgeries. Furthermore, we are living much longer than previous generations, and towards the end of life, we seem to depart the world in a different and slower manner due to illnesses like dementia, heart failure, and osteoporosis. It's also a stage of life often hindered by loneliness. Surely we are not unfamiliar with the developments of Neuralink, a promising medical science technology that could be combined with Tesla Bot to assist patients with paralysis or those suffering from Parkinson's and Alzheimer's. When Neuralink is implanted into a human skull, it will wirelessly connect to the system that Tesla Bot operates in. You can imagine it like a regular phone connecting to a Bluetooth speaker and playing music. Neuralink will analyze and decode tests from the human brain combined with facial expressions when patients try to whisper, and AI will generate speech replacements for this, ultimately resolving the issue. One thing that Optimus may do is interact with humans, but it's still unclear how that'll play out smoothly. Tesla believes the company will seek more natural interactions, making the robot friendlier and more approachable to users, potentially mitigating any uncanny valley effects that humans may experience when they're near a humanoid robot. Optimus is also expected to utilize some natural language processing procedures so that the robot can work alongside humans and understand their intentions without needing verbal signals. It's seen as a revolution in end-of-life care, enabling them to converse as well as engage in other social interactions with humans to keep the minds of the elderly sharp. Tesla's humanoid robot's concern is also of great interest to individuals in the working age group. Do you think it'll steal people's jobs? Completely wrong. It'll replace humans in hazardous jobs and those that impact human health. So, what level of dangerous work will the next generation Tesla bot perform? According to the U.S. Bureau of Labor Statistics, there have been over 2.8 million cases of workplace injuries in the United States. While this is undesirable as we value both money and health, money can often be seen as a means to ensure health, so people continue to perform these jobs. The automotive manufacturing industry has undergone a major revolution by introducing massive robotic arms into factories to perform tasks requiring high precision and ensuring safety of workers. You can see in a Tesla assembly plant, there are over 750 robotic arms to carry out assembly tasks, enabling the company to achieve such large-scale production agility. Not limited to factories, the Tesla bot is expected to extend beyond factory settings to operate autonomously in individual households. It's a personalized mechanical assistant that can even reconnect broken electrical wires while the power's still on, as it's not a conductive metal hand like those in the past. Furthermore, we are gradually moving towards a future driven by space exploration and scientific research, which serves as a great catalyst for our world, improving the lives of people worldwide in immeasurable ways. However, it's also a powerful tool that can become dangerous in certain situations. Some nuclear plant explosions have occurred in the past, and the danger is that we may have to send in rescue personnel if there's no intervention from machines. Moreover, to produce electric vehicles, we rely on metal refineries, especially steel. Steelworkers often endure long hours, harsh conditions, and constant danger. Whether at factories or construction sites, steelworkers face numerous risks affecting their daily work. According to the International Labor Organization's Occupational Safety and Health Guidelines for the steel industry, there are over 27 hazards contributing to accidents and injuries. The most significant hazards include falls, toxic substances, noise, and manual handling of heavy loads, which is where Tesla's presence is crucial. Hazardous chemicals and toxic substances in the air are a reality of life in steel mills. Improper handling can lead to chemical burns, blindness, and lung damage. Furthermore, over years and decades, exposure to toxic substances like asbestos can lead to life-threatening conditions such as cancer and lung disease. In the steel industry, temperatures and humidity are often high, and workers are exposed to extreme heat from molten metal, furnaces, and welding activities. Therefore, employees often suffer burns, heat rashes, direct contact with hot surfaces, and splattering molten metal. Yikes. However, with humanoid design and a metal frame capable of withstanding high temperatures, Optimus can handle tasks in such harsh environments. In the latest version, Elon Musk has improved the balance and overall body control, enabling it to quickly leap over obstacles. Standing at 5 feet 11 inches and weighing 121 pounds, it has the physique of a mature teenager. With it, supervisors will be responsible for monitoring the robot's work instead of directly engaging in labor. Everything we're discussing here revolves around personal safety and the health of everyone involved. So, what do you think about the notion that robots will take over human jobs? Let's discuss this opinion in the comments below, as we highly appreciate it. Based on what we've learned, the future freight transportation industry is showing signs of explosive growth, especially after COVID-19, as people increasingly recognize the dangers of the disease, leading consumers to shift toward online shopping. This has made the transportation industry hot. How will autonomous delivery robots replace delivery teams? The job of delivery drivers, especially in the freight transportation industry, can entail stress regarding work hours and traffic safety. From 2013 to 2018, the number of autonomous robots for logistics increased by 175%. This is a significant figure, and since then, this rate has continued to increase by 30% annually. The Tesla bot could be utilized in the field of logistics for various tasks, such as transporting goods within storage warehouses, loading and unloading trucks, moving parts and components to different areas of the production line, or delivering packages in urban environments. An example of the effectiveness of autonomous freight transportation and logistics is in the e-commerce sector. Managing the increasing number of daily orders with varying size, weights, and the demand for 24-hour delivery requires efficient post-order processing and mobile robots. Flexible and adaptive robots like Optimus would become the perfect tool for this scenario. According to this study, this job ranks among the top 10 most dangerous jobs in the world. Truck drivers face many hazards and risks in their work, including fatigue, sleep deprivation, the risk of accidents and adverse weather conditions, and collisions with other vehicles on the road. For the Tesla bot, it has the capability to perform more complex transportation tasks or tasks that require prolonged operation, such as completing a delivery trip on a Tesla Semi equipped with full self-driving technology, a perfect combination with the artificial intelligence within Optimus. These tasks could help improve efficiency and safety in transportation by eliminating the average resting time of a human driver. Drivers need a 30-minute break after 8 hours of driving, and within these 8 working hours, humans still need additional rest after about 4 hours of alertness. Optimus doesn't care about this because it's designed to operate continuously until its power runs out and it's recharged. In terms of software, Optimus's central computer processes visual data from multiple sensors so it can recognize the surrounding environment while driving. It also has a visual localization system managed by end-to-end neural networks that have been fully trained to navigate. It contains a library of natural motion references. Essentially, engineers have recorded human motions, such as picking up a box from a shelf, and map that motion data, which has been optimized to adapt to motions in the real world within Optimus's field of view and help it handle the steering wheel most efficiently. Although the Tesla bot is currently limited to balancing, arranging objects, folding clothes, and is expected to be able to sew, despite all these capabilities, Optimus still seems to have a long way to go. But hopefully, one day, if not yet, Optimus will be able to climb stairs, pick up boxes, use tools, and perform other useful tasks in factories and households. Tesla's humanoid robot Optimus operates based on a neural network and clusters of cameras on its face, which extends its capability in some vision-required tasks like driving. Moreover, it seems to be a useful tool in large stores like Walmart. So, what can it do with high-quality camera clusters in supermarkets? Scanning barcodes in supermarkets is a seemingly easy task, but for employees who gotta do it day in and day out, the repetitive nature of the work can lead to boredom and musculoskeletal problems such as back pain. Optimus can confidently take on this task, as its camera system can be linked to the supermarket's management system to scan barcodes for payment and also organize goods on shelves every day without needing a break. Retail stores will gradually replace their employees and let robots do the hard work of managing retail shelves. Retail inventory robots can check inventory levels, ensure plan compliance, verify prices, and alert employees to issues like things that are out of stock. This data and error reporting is collected in real time and sent to store management and associates for action. This will lead to a better shopping experience for in-store shoppers and pickers, reducing wait time, increasing overall sales, and reducing costs for the store. Since most people go grocery shopping during regular hours, they don't see the overnight stockers who come out late at night and work till the sun comes up. Those jobs aren't threatened yet, but the concept of overnight stocking may be coming to an end for other reasons. With nearly 12,000 stores, Walmart is the world's largest private company with 2.3 million employees. About 1.4 million of those employees work in the US, and that number is likely to go down before it goes up. Walmart already has plans to shift those overnight stockers to daytime stocking. Previously, one of the tasks that daytime employees had to do was check inventory by manually scanning the shelves. If you think about the size of a typical Walmart store, you can easily see how labor-intensive this task is. This may help explain why inventory was only taken about twice a week. After all the capabilities that Tesla Bot can operate in its factories, hazardous environments, or large supermarkets, there's one simple thing that robots can replace humans in every household, which is cleaning and tidying up. There might have been times when we felt too exhausted to clean up our homes after a long day at work, or elderly individuals may not have the physical strength to keep their homes sparkling clean and trim the branches in their beloved gardens. Tesla Bot will replace them with dexterous hands and a total of 28 drive units that allow it to move freely. Furthermore, cleaning tasks in large public areas such as schools and hospitals can be exhausting for janitorial staff. And some individuals may even find it uncomfortable when cleaning staff makes the floor slippery with cleaning agents during the day. However, there are no janitors working at night to avoid encountering this issue, and robots can fill this gap. They can operate at night or during breaks without disrupting those around them. Finally, for restaurant services, both serving and cooking in the restaurant industry require the ability to work in a high-pressure environment with flexible working hours. Everything seems to be time-sensitive when serving customers, especially in high-standard restaurants. Tesla's superior technology can create surprises for customers when present in restaurants. The working environment of chefs in the kitchen is also a stressful position during peak hours. We don't think robots can perform the job of a chef well at the current stage when agility hasn't reached such a level. However, when reaching a certain reasonable level, this idea is no longer a science fiction movie that we mentioned in the opening scene. Serving robots and kitchen robots can greatly reduce stress and create a much more efficient working environment. Elon Musk noted that Tesla Optimus has quite a big advantage over robots produced by other companies today. The same artificial intelligence hardware and software infrastructure that Tesla's developed for its fully self-driving cars will be used for the Tesla Optimus humanoid robot. Even the hardware for installed in the company's latest cars will be used as the brain of the Tesla robot. Tesla's AI vision gives Optimus the ability to perform tasks more freely, unlike other robots that can only do what they're programmed to do. The Tesla Optimus robot can actually see the world around it, recognize objects, and make decisions about what to do using AI. What do you think about these insane abilities of this new generation Optimus? We hope this video provided you with a sense of relaxation. If it resonated with you, kindly show your support by liking the video and joining the Tesla Car World family through subscribing to our channel. Be sure you don't miss out on any of our fantastic content by hitting the bell icon. Your feedback and time are immensely appreciated. Thanks for watching, and we look forward to seeing you soon. Until then, stay safe and enjoy life.